Good morning, boys and girls. So today's math lesson, we're going to start with this essential question, which is how can you find the sum of three addends? And let's remember that the word sum means the answer to an addition problem, and the addends are the actual numbers that you were adding together. Last week, we talked about something called the commutative property, which I put some flip-flops here because you might remember that we also kind of refer to it as the flip-flop strategy. And we know that that means if you have an addition problem, that you can flip-flop the addends, but the sum is going to be the same. So this one we have 6 plus 2 equals 8. And if you look over at the number bond, we have our 8 as our sum, and then our two addends are the 6 and the 2. And we can flip-flop the addends of 6 or 2 into 2 plus 6, and it equals the exact same sum. So that, again, is called the commutative property. Well, today when we're adding three addends, we're going to learn a new fancy word called the associative property. And this associative property is going to be very important when you start learning multiplication and division in 3rd and 4th and 5th grade. So, the associative property states that changing the way that numbers, addends, are grouped does not change the sum. So if you look at our example here, the first number sentence I have is 2 plus 3 plus 5. And I said that that equals 10 because what I did is I just added them in order. 2 plus 3 I know is 5, and 5 plus 5 is a double stacked equals 10. Well, what I did is I changed the order of the numbers. I grouped them in a different way on the next number sentence, and I started with the 3 instead. And I still got the same sum of 10. 3 plus 2 is 5, plus 5 again is 10. And then the last example, I used the exact same addends and I grouped them in a different way. I started with the 5, and then I added the 3 and the 2, but guess what? Yep, the sum is totally the same in each one. So for the associative property, that just means if you have 3 or more addends, you can add them in any order that you want. Now, it's very important to remember this only works for addition problems. Subtraction is very different. Okay, so we're going to move on and do a really quick example. So I have a problem here, 3 plus 2 plus 7, and I use my counters just so I can give a quick visual. I wrote it two ways. I wrote it as a number sentence, and then I wrote it vertically, which means up and down. And it doesn't matter each way. Either way that you write it is correct. It's whatever you kind of feel more comfortable with. So for this problem, I'm going to add it a couple of different ways. So first, I'm going to make a 10 because I know that making a 10, usually if I can see a tens fact, I can do it really quickly. So I'm going to circle my 7 and my 3 because that jumped right out to me because I know that 7 plus 3 makes a tens fact. So now all I have to do is add my 2. So I've got 10 and 2, which I know in my head is 12. Now, if I wanted to do it a different way, I could because some of us might look at it and say, oh, well, right off the bat, I know 3 and 2 equals 5. And that's very fast for me to do. So now all I have to do is add 7 plus 5, which I know is 12. So what do you notice here about the sums of each problem? That's right, they are exactly the same. They have the same value. We didn't change the problem. We have the same addends. We just put them in a different order. So today you're going to be working in your math book on using this strategy, the associative property. I'm going to have you get started in your math book, but I'd like to show you a math on the spot video that will probably help you with number 19 in your book today that you're going to work on. So I'm going to go ahead and play that video for you. You know what? Before I play the video, let me just show you what we're going to do independently. So for independent work today, you're going to work on page 183, which if you can see, it's just a bunch of addition problems with 3 add-ins, but really pay close attention to these directions here because it says solve 2 ways, circle the 2 add-ins you added first. So if you notice number 7, these 2 problems are exactly the same. So they should come up with the same sum. But what we need to see from you is that you are circling the 2 add-ins you started with first, just like Miss Mac did over here on the examples. So you're going to do this whole page, and then if you look down here, this is a little bit more challenging because they're written vertically and there's a missing addend. So you have to discover the missing addend, not the sum. So if you looked at 15, we know that 5 and 5 is 10. Well, now you have to think to yourself, okay, 10 plus what will get me to 14? That's right, 10 and 4. So you would write the number 4 in this box. You're also going to work on page 184, which these are more word problems. So let's remember our UPS truck strategies. And this one is our math on the spot. So I would like to show you the video for math on the spot, and then we're going to let you do some independent work for page 183 and 184. And you don't have to rip these out of your math book. You can keep them in your math book, and Miss Mazer and I will check them when we get back to school on Thursday. So let me get to our math on the spot video. Oop, I went the wrong way. It's probably staring right at me. There we go. Okay, so we are grade 2, chapter 3, lesson 3.4. Here we go.
Hi everyone! Jeannie, today's math puzzle has to do with raisins.
Great! Raisins! Oh, I'm so hungry!
No, Jeannie, they're not real raisins. They're in the math puzzle.
Oh, silly me! I forgot.
Are you ready to help me solve the math puzzle?
Of course!
Nick, Alex, and Sophia eat 15 raisins in all. Nick and Alex each eat 4 raisins. How many raisins does Sophia eat?
I don't know.
Let's take a look at the information that's given to us.
Okay.
We know there are 15 raisins in all, right?
Yes.
Or actually, we know that that's how many Nick, Alex, and Sophia eat.
Everybody eats.
Nick eats 4 raisins.
Okay.
Alex eats 4 raisins. And Sophia?
We don't know.
We don't know how many raisins Sophia eats. And that's what we want to find out.
Oh, good. Let's find out.
Okay. Now, if they
What do we know?
Right. If they eat 15 raisins in all,
Yeah.
that means we want to use addition.
Right.
Yeah.
Right.
We're going to add the number of raisins. Here's my addition sentence. The number of raisins Nick eats, plus the number of raisins Alex eats, plus the number of raisins Sophia eats, which we don't know how many,
We don't know yet.
equals 15.
Okay.
So the first thing I want to do, Jeannie,
Yes.
is I'm going to add the 4 plus 4. So we have 4 plus 4. What does that equal?
That equals 8.
Correct!
Like I ate raisins. Oh, I'm hungry.
So now we have that the 4 plus 4 is 8.
Mm-hmm.
So I have this
Right.
addition sentence
Oh,
that just follows from the one above.
Got it.
Okay? So 8 plus one number equals 15. Can you think of the number? If you said 7, then you are correct.
Good for you.
So Sophia eats 7 raisins. Now we can get rid of this question mark because I know the answer is 7.
Yeah. Ah, that was so great, Mrs. Sandoval. Thank you.
You're welcome.
I learned a lot about math today. And you know what else I learned?
What?
I learned a lot about Sophia.
Oh, is that
She
right?
really needs to share more with the boys.
No, Jeannie, Sophia's not real. The raisins are not real either. They're just in the math puzzle.
But those poor boys, maybe we should bring them some more raisins. Yeah. Do you have your car keys? Where'd you put them? We should really get some.
I'll see you next time and join us for some more fun math riddles.
Yeah, see you later.
No.
Can we go to the store and get some
Jeannie,
raisins?
it's a math
Okay. So, again, you guys are going to be working on page 183 and 184 during independent work time, and we will see you at our next Google Meet. Bye, everybody.